Okay. All right, I think we'll give everyone a couple minutes to join here. Just hang out for a minute. But if you're just joining us, we're just going to wait a little bit longer for some other people to join. Probably get started in about a couple minutes here. Okay, I think I'm going to go ahead and get started here. We can go ahead and get to the first slide here. My name is Brendan Duncombe. I'm the Director of Customer Engineering here at Macrofab. I've typically been on the product side as opposed to the manufacturing side. So a lot of my previous work experience is in, building some consumer electronics. I did a lot of work in automotive space for a little bit, and a bunch of full stack products. But recently I've switched over to the manufacturing side, and a lot of my focus now is on how can I help customers and their specific designs be built, give some DFM feedback, things that they need to look out for when they get into manufacturing. And today we're going to talk a little bit about how basically the deadlines are getting tighter and tighter all the time. And I want to go over some topics that we can use to help us be a little more agile and kind of front load some of our work. So typically, when we talk about tight deadlines, you always feel the pressure at the end. Oh, I want to say one other thing. Please feel free to ask questions as we go. I'm happy to pause and answer anything as it comes up. So go ahead and use the Q&A area to input your questions and I'll see them. Anyways, as I was saying, tight deadlines are almost always felt at the end of a project, right? Very rarely are you at the beginning of a project, and while you may see the road ahead looks like it might be kind of tight, it's really like that last hour when you have all your stuff splayed out on your desk with the probes trying to figure out what's going on with your design, that you are really starting to feel the crunch, right? But there's also another kind of deadline that we don't like. If you're doing the hardware side, it doesn't necessarily directly affect you, but a lot of times hardware is kind of the beginning of a project. And so a delay on the hardware side often ends up in a big crunch for our cross-functional team members. If you've been a part of any full stack product, you know that your firmware developers, your software developers, the mechanical engineers sometimes even are all like, well, when the hardware is ready, we'll be able to test the next thing. Or, we won't be able to, code against feature X and X until we get the new revision. And oftentimes a lot of that delay can really compress our cross-functional team members' schedules. And so I want to go over a couple strategies to deal with some of that. Specifically, we'll talk a little bit about Agile philosophy. That's a massive topic, so we'll just cover it briefly. And then I want to focus a lot on the basic infrastructure you can implement to help keep you agile, which I know sounds a little bit of a oxymoron, like add some process to keep you agile, but I promise it'll make more sense. And then I want to talk about a topic that is getting, I think, a lot more traction, which is test-driven development for hardware. Some industries that have like extremely high testing requirements do this already, but I think that it can be used in a lot more industries than it currently is. Next slide, please. So when we talk about Agile, I think it's really important to remember like what the core ideal of Agile is, right? This is the Agile Manifesto. I think you can go to agilemanifesto.org to find it, right? It's just a very simple web page that goes over that is individuals and interaction over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. Everything else you've ever seen built up on top of Agile, like Scrum and other frameworks, is not really necessarily like the core of what Agile is. So I know that some people get put off about, talking about like, hey, we should do Agile. And they're like, well, I don't want to attend like daily stand-up meetings and things like that. All of those are just frameworks that hope to help further this goal of being nimble. And you don't necessarily need to be doing all of that. Like there are practices you can put in place to help you stay nimble that are not necessarily like implementing like sprints and reviewing your burn down charts and doing all of that, right? You can just make some simple choices that help you be more agile. And again, in my opinion, the core of this is being able to respond to change very quickly and getting early feedback to generate that change, right? If we go to the next slide, you'll see like the core of it is this loop of the design, build, test loop. And that only works when you get early and continuous feedback, right? And to be clear, it's not incompatible with other development models, right? Like the standard V model should still be used if you're using it. You just want to, inside each of those steps, be trying to implement these small little like design, build, test loops at each of those stages, because there's nothing worse than getting all the way to the end of a product at your development cycle, getting a bunch of feedback that causes you to rip everything up. You want to get that feedback as early as possible. So let's go ahead and go to, the last thing I wanted to say here, sorry, I'm tricking you. The last thing I want to say there is part of that is also more prototype development. I see a lot of projects go through where at the initial phase, there's implementation on dev kits to vet out the basic process. And then sometimes I see projects go all the way through where they don't make another prototype until they're doing their pre-production prototypes. And that makes it very difficult to get this early and continuous feedback that we've been talking about. And so another key aspect, I think, of Agile hardware development is that we have to be a little bit more comfortable prototyping more often, or doing prototypes, maybe that's not necessarily your whole design, at least prototyping parts of your design regularly to get that feedback. Okay, now we can move forward. So some of the things I want to talk about, like these infrastructure and process, again, which sounds a little bit backwards, but the whole point of implementing these is to move some of the things that you end up doing later on in the process, much earlier in the process, and leveraging it across all of your projects. We all have experience with the first one. It's a form of infrastructure that you all are using when you're developing hardware. Like you're definitely using your design rule checks, right? Typically, I would say like 90% of people are using some version control system, and these don't have to be a super heavy lift, right? You can have like a bare basic DRC and version control process where you just are incrementing a counter or something. It doesn't have to have any additional meeting, but it's extremely helpful. We've all been in a situation. There's nothing worse when you have products out for testing and your beta testers are using it. You get some feedback only to find out, well, actually they have the wrong version or an older revision. I've been doing debugging in the totally wrong spot. it's important to try and like keep your version control going early and often. Like even the very first design that you ever push, give it a version number, start counting up. You don't have to release at version 1.0. I do sometimes see like a little bit of trend there where people are like, okay, 0.921, 0.92, trying to get there. It's okay. It can just be a counter. It doesn't matter. Another thing that I personally really prefer, and this is a habit I made when I get prototypes developed, I change the color mask on every prototype I get made, if possible, so that even from across the room, when someone's testing or if they open up your product, they can tell you instantly what hardware revision they're running because they've got a bright orange board or a bright, purple board that tells them, okay, this is hardware version X. I think that can make it a lot easier. The next thing is review and release process. Again, doesn't have to be super heavy-handed. It would be great, right? There is like an end state of a review and release process where you can be doing like automatically running DRC when you push. It generates all your CAM outputs automatically. It loads all the files into your PLM. It does all of that. It doesn't have to be that though. Again, the goal is to get this early and continuous feedback. So someone else should be reviewing your design before it goes out. There's nothing worse than, designing completely in a vacuum, pushing it all the way, getting a prototype made, and finding out you made a very silly mistake that would have definitely been caught if someone else looked at it. And the release process, again, it just needs a little bit of documentation, a little bit of sign off where, the documentation can be as little as just a change log, but something to make sure that everyone who's collaborating on your project knows what's going on. You want to be able to collect feedback on what's actually changed. You want everyone to be on the same page so they know what feedback to be giving you. And all of this is like a little bit of extra process that just helps you get that feedback in a more efficient and better manner. The next two are a little bit, I think, harder to achieve, but they're extremely important for full stack projects. When we talk about full stack projects, again, as we were talking before, there is always this schedule compression with our cross-functional team members when we're doing a full stack product, where they can't really be testing aspects of their design until the hardware is sitting in front of them or they have something to develop against. I've been a part of many projects where like the cloud version of the connected application or whatever is like the cloud side is amazing. They've been testing that for months. Everything works great. They've had ample time to do that. And then, the Bluetooth implementation or something else is like rushed at the last minute because they didn't have anything to target against. Building simulators to accelerate the schedule for your team members, I think is a huge benefit. And again, you can get feedback early on saying like, hey, I'm having trouble with this Bluetooth module or whatever your connected feature is. And you want to be collecting that as early as you can. And one of the ways to do that is to get something that's representative in front of your teammates, even if it's just whatever you did for your dev kit prototype, but made a little bit more robust that you can deliver to a bunch of people. That's a great start and will really help you respond to change more easily. Because if you need to make change in hardware, you can make that change quickly to that dev kit thing and have the software team respond as equally fast. The last thing is I think hardware developers need to pay some special attention to our firmware developer colleagues. These are our closest collaborators most of the time. And we just want to make sure that they have a development environment set up that is repeatable and reliable so that we can unblock them through the whole process. They shouldn't have to dismantle half of the product or the prototype in order to be able to flash it. The whole process for like releasing a new version and like having UART coming out and all their debug signals shouldn't be that they like dismantle everything, try and probe it on their desk. It needs to be a little bit more robust than that. They need to be able to deploy firmware quickly. They need to be able to get reliable data back from the device all the time, even if it's like battery powered or needs to move. Early on, we should be trying to design as much as possible for a good, consistent firmware development environment. And again, the reason we're doing this is to collect that feedback, right? We need to know if the firmware developers are finding issues with our layout or any of the peripherals we've chosen. We want to collect that early enough, and having to wait for them to be able to deploy or making them inefficient in their job makes it a lot more difficult for us to respond to change. Any questions? If not, we'll just move on. So the last one, and this is kind of a bigger topic, but I think that there's more room for test-driven development hardware than kind of what's been explored so far. But if you're not familiar with test-driven development, the idea is like kind of the core principle you'll see in the software world is that you write a unit test or any type of test, confirm that that test fails, and then write code to make it pass. Again, the idea being that your test set drives is driven from your specifications and drives the way in which you should develop everything. You can actually go even further than this. There's kind of this thing called behavior-driven development, or BDD, and there are some frameworks out there where you actually write your specification documents with a syntax such that it can be used to automatically generate the test set. And so you kind of have this one source of truth living document that is both your spec and your test set, and all of that gets automatically generated. I think in hardware, we don't go necessarily that far, but I think the idea of having a test-driven development cycle is very powerful. And in a lot of ways, hardware is not that much different from software development, and that we already do this, right? We are already developing detailed hardware specification documents. Typically, we're developing test plans, usually very early in the process. We're developing test plans for our hardware. The only part that we really deviate is often you'll see projects happen where the test plan doesn't actually get run until pretty late in the process. And I think that that is kind of a little bit wasted effort, right? We're going to go through all of this, and at the end of the line, we're just going to run everything. Well, we could be collecting that feedback on portions of our design much earlier in the process, right? And if we start the project with test-driven development in mind and what that test plan is, we can, get a lot more bang for our buck for all the effort we went into writing the test plan. This goes even further when you get into automation, right? Like most of the time when you're testing, you are sitting there with probes, or you've got it hooked up to some like actual real peripherals that it's going to be controlling. You're maybe evaluating your waveforms by eye, things like that. There's a lot of like manual testing going into it. But it's important to keep in mind, at the end of this process, right, when we get all the way down to the end and we're ready for manufacturing, you're going to have to build some sort of test fixture anyway, right? Your manufacturer is going to need something to test all of your hardware. And my suggestion is, if you can get more value out of that test fixture early on in your process, so like maybe build a test fixture alongside your first prototype, then all that effort that you were going to put in for manufacturing, now you get to reap the benefits of it throughout the entire development process. Increasing the level of automation you can get in your test setup as you go makes you a lot more efficient, and again, is all feeding back into this like very small design build test loop, where like each prototype you can load back in your test fixture for regression testing as you go through. And not only for being agile, I think one of the things that gets often overlooked is these automated test sets that can run through, that are very repeatable and can run through like very big test plans, gives you a level of confidence in your design that I think is totally worthwhile. There's nothing worse than having to make a small change to the board or something, like, yes, it shouldn't really affect it. You've got a tight deadline. You test that one piece, you maybe don't do a full test on it, and then you're nervous about it the whole time. Having something that's automated where you can just load the whole test plan in, every change you make, is a lot of peace of mind and helps give us a lot of confidence in being able to make changes, which is at the core of being agile, right? You should be able to make changes often without having to worry about breaking everything. When we talk about automation, you can also use a little bit of automation to actually build the test fixture, right? Your EDA tool has where all of your test points are, right? You should be able to use that to automatically generate where you need all your pogo pins to go. With a little bit of extra work, you can use that to generate the holders for the pogo pins as well. So if you ever need to do that, there's a little bit more automation you can bring in there. And lastly, the things to keep in mind, I'm going to reiterate this one more time. I'm currently working on the manufacturing side. You're going to have to build some sort of test fixture at the end, no matter what. Again, let's take advantage of that. Like that's work you're already going to be doing. Let's just do it earlier in the process, design for it in mind, because it helps two things, not just getting more use out of a test fixture you're going to build in, but then the test fixture you're going to hand to your manufacturer is going to be a lot more robust, right? Part of the product you develop, that like you deliver, it's not just the end hardware, it's also the test fixture, one of your work outputs. And so having that be more robust because you've been using it through the whole development process is, another synergy that's totally worth pursuing. The other thing, like these are just some minor notes too, like test points are basically free. If you have room on your boards early on when you're building your prototypes, like litter test points everywhere. If you can get them on every net and you have the room for it, why not? At some point, you don't want to be in a position where you're like, trying to clip your probes onto the edge of ICs, or you're adding like green wires to try and get to traces, scraping off solder mask to get to something that's like impossible to probe. Put test points down. You can always delete them later. It's not a firm commitment, but it gives you a lot more flexibility in your and debug skill as you go through. The last thing I'll say is like, there can be a concern that doing all of this means that every time you make a change, like if you build these test infrastructure and other infrastructure processes, every time you make a change, you have to, like, it affects more things. But the reality is that if you can just generally keep the test points in the same spot, your test fixture will be basically the same, unless you like dramatically change your functionality, which in case you are going to have to change a bunch of things anyway. And then even if you do move the test points around, the test equipment and the functionality that you were using to test in the first place is still the same. And so all you really would have to change is, whatever your interface to the board is. Now, designs that use that all of the interfaces via connectors, that's even easier, right? You can totally skip the pogo pins and stuff if you want and just give yourself a little functional tester there. And by interfacing with the pins itself. The other thing you can do with this is this fixture, this setup can be what you deliver as a simulator to other teams, right? It has the ability to check inputs and outputs. Your firmware devs will love this, being able to like directly flash into a fixture, make a change, watch all the outputs change on the test fixture. It's a great development environment. So there's even more you can do with this. If any of the work that you're going to have to be putting in at the end, if all of your teams can take advantage of it when you're building a full stack product, it's completely worth it. And that's kind of all I have for today. So I'll open it up for questions. Okay, well, if there are no more questions, I can hand it off to Veronica.
Thanks, Brendan. That was great. I hope y'all had enjoyed the webinar and will attend our next one, which will be September 26th on a Tuesday. It'll be noon as well, 30 minutes. At that webinar, we're going to have Misha, our CEO, and also the CEO from Fictive, Dave Evans. The webinar will be covering manufacturing resilience, how to thrive amid market volatility, and it'll be a dual perspective between Fictive and Macrofab. Also, if you happen to be in the Houston area, we are having engineer meetups, and we hope you can join us. You can find that information on our website, macrofab.com. And keep an eye on your inbox. We'll be sending you a treat So I hope you'll have a good day. Thank you. Bye.